So let's find out what's new in this project, and I'm going to click View, Solution Explorer, and under Source Files we have a new source file, model.cpp. So model.cpp is implementation of the new C++ class that is trying to represent the actual geometrical shape or mesh or model that we'd like to be able to render in our OpenGL program. So first let's examine what this main program does, and it should be quite similar to the example that we already explored. Right here I have a quick overview of our OpenGL client program, and our application initialization stage is happening in our main function. So let's find out. So initialization of glut and glue is obviously done right here. We initialize glut, we open our window, we configure all the components. Then glue initialization is just a single glue init call. So now OpenGL library is ready to be used. So this is done. Then we compile and link the shaders. So again, this is now done. The compiling and linking the shaders is done right here. We just instantiate the shader object dynamically and pass the path to vertex and fragment shader. And then there is a new component that we would like to be able to load multiple models. And here we use one model as an example, and it happens right here, right? So we call new model, and this is new object, new class that we're going to explore in this laboratory. And notice that under current design, the model is accepting this shader as a parameter. So this is constructor of our model, so it takes the pointer to the shader object because this shader, for the sake of simplicity, this shader will be automatically used by the model when we start rendering. Then, of course, you see that we have the same set of vertices and colors that we've already seen in our example earlier. And then what we do is we connect these vertices and colors to our model. So we basically tell the model object that those will be your vertices to use and those are the colors to use together as vertex attributes. And then there is upload to server, which encapsulates all those low-level computations about finding out where the memory position should be for loading these vertices and colors, and actually uploads this to OpenGL server. And then we go to glut main loop, and the next thing that happens is the render. Okay, so application render. So what it does is right here, this is our render function. So it clears the background, removes everything from the background, and it simply calls model to render. So we had multiple models to render. We could just do this call model render for multiple models. So this simplifies our implementation of render very nicely, and keeps everything organized, and we begin to sort of focus more on high-level use of our model rather than low-level OpenGL API calls. And of course, swap buffers makes the new frame visible. Okay. So now it's time to look at the functionality of the new class, the model class. So first I would like to go to our source subdirectory, and of course the model CPP, which is included on our in our list of source files, has the corresponding header file. So I'm just going to drag and drop the header file right here to open it. And let's see what this model is capable of. So this is the public interface. We have constructor, which takes pointer to the shader. We have the destructor, which takes care of any kind of dynamic memory allocation and other things like cleanup tasks before the model object is destroyed. And we have these very useful things that we say set geometry, where we can accept the vertices. Set normals, which will set up in the future, not right now, but in the future, we can set up an array of normal vectors for our vertices, which will become additional vertex attributes. Assert vertex colors, that's exactly what we want in our example. We want to be able to specify both vertices and colors. In the future, we also plan to add textures to our surfaces, so that's a different story. And upload to server is basically go ahead and whatever we supplied already, we can upload to the server, and the rendering code is supposed to make it visible. So below here we just have some private data that is retained by the model object. Of course, pointer to the shader. So this is the our vertices, basically a pointer to an array of floating point numbers, and that's an array of all the vertices. Similarly, array of normals, texture coordinates, colors. We already know that that's the same thing. The colors for every vertex. Then we also keep track of how many total vertices and how many total colors and everything else we have here. So this may vary. Sometimes vertex components can be XYZ, and sometimes can be XYZ and W. So basically the size of this array may not exactly be representing specifically the size of every component. So that's why we, besides keeping this, we also keep the total number of vertices and colors and everything else. So this is all familiar vertex array object, which allows OpenGL to understand the structure of our attributes, vertices, colors, and everything else. This is array here is synonymous to structure, the structure of data that we will be sending to our GPU. And VBO represents the handle to a buffer, which means a handle to memory in our GPU. So buffer is synonymous to memory, and array is synonymous to structure. So because OpenGL is an old API, and the terminology is not always intuitive, but I'm trying to guide you a little bit through those things. And remember that we have the possibility of supplying positions and colors. So these are handles to input variables in our vertex shader. So we may not use them all, but at the minimum we'll be, in this lab, we'll be using position and color. So this is the interface, the internal organization of the model class. So the new object, so remember the way we use it, we say, let's create new model, and it accepts the shader, and then we just set geometry, set colors, upload to server, and finally we render. So everywhere the model is used. Right now in this demo we only have one global variable, which is a pointer to the model because we created dynamically, but in the future we're going to start using like arrays of models, because we will have multiple models in our world. But for now it's just one single global pointer, which is automatically available to all of these functions.